Hello there, ROS developers, and welcome to live class number 89. And today we're going to be talking about ROS Publishers. So if you want to know how ROS Publishers work, stay here because this is the place to be. So let's start. Let's go. So hello everybody and welcome to live class number 89. As I've just said, today we are going to be talking and discussing about ROS Publishers, what they are, how they work, how to create them, different types and situations to work with ROS Publishers. But before everything, let me say hello to you guys, to the chat, and let me know if everything is fine, sound is fine, video is fine, so that I can keep going. So I can see there Kaput, Sujay, Engineering Nations, Guess Me, Sadok, Gloria de Felix, Panduru, Martin Schmidt. Okay, so hello everybody. I'm happy to say hello to all of you guys. And let me see if somebody can give me some feedback. Everything is fine. Sound and video are good. Okay, excellent. So let's start. Then, as always, first of all, let me share with you here in the chat the live class for today. So let me get here real quick the link to today's project. In fact, let me right now switch to the PC camera, so I will see you when we finish the class again. Before everything, as always, a bit of coffee from my ROS developers Mac, and now we are ready. So see you in a moment. Bye bye. All right. So here we are in ROS DS, in my ROS DS. So I'm going to real quick grab here the link for today's project. Let me verify. It's 89 ROS Publishers. Yeah, it's this one. So let me get this link here, and I'm going to paste it to you guys in the chat. There we go. Excellent. And as always, once you get the project, just it will appear here in your projects workspace here in ROS DS, in the ROS Development Studio. Yep. And then just click on open and open project, and everything will start loading. So I'm going to do that right now. Hope there's not any problem with the project I shared. Hopefully not. For the new ones, remember, if you already have a ROS DS account, excellent, just get the link and you will get their project. If not, you are going to need to create an account here for the ROS Development Studio. You can do that in a few seconds. It's totally free, so go for it. And all of you, please, as I've just done, start opening your project. Here loading, it will take maybe 1 minute or something like that. But meanwhile, I'm going to talk a little bit. Meanwhile, mine is loading. So as always, I want to invite you, all of you guys, to our Discord server, our ROS study group, which you can come here by clicking on this link at the right bottom side of the website. And here you are going to be able to access our Discord server, our Discord community, which is growing each week. We are now really close to 500 members, which is great. So all of you guys, if you are not yet, please enter our Discord community, where you will find many people interested in ROS, in learning ROS, in creating ROS projects. So this is really the place to be for ROS developers. Yep. So don't miss it, guys. And secondly, I want to remember you also, as always, our ROS Death day, which we are preparing. and it's going to be real soon, in the 27th of June. Yes, so we are now in May, so a month and a half, let's say, a little bit more. Yeah, so it's real close, and it's going to be a full day where we are going to have several virtual conferences, virtual speeches, yeah, presentations of different ROS experts and about different ROS topics. Each conference is going to be about a different ROS topic, and it's going to be super interesting because besides the conference and the knowledge that our speakers are going to share with you, you are going to be able to practice everything you learn, as we always do in the ROS Development Studio. So meanwhile you are listening to the conference, you're going to be able to practice all those concepts into ROS DS, yes, into real simulated robots. Yeah, so if you are interested, guys, don't miss it. Really recommend it as well. And have a look here at the webpage and register, because it's going to be real cool, really nice. Yeah. All right, so let's close everything right now and let's go back to our project. Here we have it. Here I have mine already loaded. Here I have my notebook, and as always I'm going to start by opening the simulation. So here we have the ROS Developers live class number 89. This is the project you should have for today's class. And for setting up the environment, we are going to be working today with RB-Kairos from Robotics, a really cool robot. And in order to start the simulation, you have the instructions here. I'm going to come right now to the simulations button here at the top menu, and I'm going to select this launch file, rbkairos_complete.launch, from the RB-Kairos sim bring up new package. So I'm coming here, I click on the choose launch file button, and here I need to search for the RB-Kairos sim bring up new. Here I have it, yeah, in bold letters, RB-Kairos sim bring up new, and from here I'm going to select the RB-Kairos complete.launch. So I'm going to click here in the launch button, and this is going to automatically open a gazebo window, and it's going to start loading my gazebo simulation for the RB-Kairos. So once it finishes, I should have something similar to this, with the RB-Kairos robot here in this kind of office environment, let's say. It's going to appear in a moment here. Let's see. Also, let me remember, as always, for this live class, you should have a minimum knowledge of Linux and Python, yes, because we are going to be working and creating programs with Python, and the OS, the environment, it's Ubuntu 16.04, as you can see here. So you need to have some basic knowledge as well of Linux and Linux command tools, basic Linux command tools. Yeah, and you can get this knowledge here in our free courses from our academy. They are completely free. You can complete them for free. They are really interesting, so I really encourage you to have a look at them. Here you can see all the content you are going to be able to learn from them. And we have these two, which are the Python 3 for Robotics and Linux for Robotics, which are completely free. Yeah, all the other ones are paying courses, but these ones are for free. So yeah, if you have time, and probably many of you have time now these days because of this situation we are suffering, so guys, have a look at it. Yeah, probably you are going to learn something new from them. And when you complete them, you can come here to the path, to the prerequisites path, and do the exam. Complete the prerequisites exam, where you are going to be examined about Linux and Python, and you are going to be able to get a certificate. Yeah. All right, so yeah, let's close this. So at this point I am prepared, I am ready to start with the live class, so you should all be here at this point. Here I have my simulation loaded at the right side, and here I have my notebook at the left side. So I want you guys to be at the same page as I am, at this same point, so that we can start all together doing the live class. So let me know, guys, please, in the chat, in the comments, if you are at this point, you have the simulation loaded, the notebook opened, and you are ready to start. Because as I always say, guys, I want you to be practicing with me. Yeah, so at At the same time, I'm going to be explaining things and creating programs. I want you to be listening to me, of course, but also practicing everything that I am doing. Yeah? So let's have a last look here at the chat. Let's see how things are going. Hello from Germany, says RZ. Hello there. Hello from Spain. Hey there. Hey, hello. Yes, ready. Okay, so are you, all of you guys, ready to start? Ready to go. I can read there. All right, excellent. I can see there Andres is asking, which is the launch file that are we supposed to open? You have it here in the notebook, Andres. You can see here the launch file. From the package RB-Kairos in bring up new, select the launch file RB-Kairos _complete. Yeah, so here you have the instructions in order to load the simulation. All right. Then let's go for it. So yeah, ROS Publishers are one of the most important elements in ROS. That's true. So if you master ROS Publishers and ROS subscribers, yeah, let's say that you are going to be able to create almost any program in ROS, yeah, because all the complex ROS programs like can be more complex ROS elements like ROS services, ROS actions. At the end, they are wrapped around ROS Publishers and subscribers. Yeah. So in the core, ROS works with publishers and subscribers. So if you master ROS Publishers and you master ROS subscribers, which are the last two live classes we have done. Last week we did subscribers and this week we are doing publishers. If you master these two concepts alongside with topics and messages, I would say, you are going to be able to almost create any program with ROS. Yeah. So they are really important, and they are really important because ROS works, one of the main features, let's say, that make ROS so powerful is the ability to work with data flows, yes, independently of how this data is generated, or independently of the hardware, let's say, which is more or less the same, yeah? So here I have a graphic where I basically explain this, yes? So ROS works with topics, yeah? Topics are like empty pipes, let's say, that can contain data. Yeah, this would be a topic, which is here drawn as an empty pipe, and inside this topic there is going to be data. Yeah. Then around this topic we can create ROS nodes. Yes, well, around this topic or other topics. Yeah. But then we have the ROS nodes, which basically are the ROS programs that we create. Yes. Then each ROS node, each ROS program can either publish information into this topic, so place information into this pipe, into this topic, or read information from this topic or from this pipe. Yeah. So for instance, this ROS node, we could create it as a publisher, and this ROS node then will start putting information into this topic. Yes. Then these other two ROS nodes, for instance, we can create them as ROS subscribers, and they would just read this information from this topic, get this information from this topic. Yeah. Then last week we focused on ROS subscribers, and this week we are going to focus on ROS publishers. Yeah. So on the ROS nodes, the ROS programs that are meant to publish data into a topic. Yes. So far, so good, guys. So we are going to focus on the ROS nodes that can publish data into a topic. All right, then, first of all, we are going to see some command line tools related to this concept of topics and ROS programs and publishing and subscribing from information from them. So, first of all, if we want to know which ROS topics are already running, yes, we can use the ROS topic list command. This is going to give me a full list of all the topics that are currently available in the system. Yes? So here I can see a full list with many different topics. All these topics are currently running. Yes? So are running and are available, are there. Are available for me to read information from them or to publish information into them. Yes? So all these topics are already running. Then, if I am interested in knowing more data about a specific topic, I can use the ROS topic info command. Yeah? So, for instance, I'm going to get more information about the TF static topic. This last one I have here. So I would write here ROS topic info TF static. And this is going to give me information about this topic. Yeah? This topic, in this case, it's telling me, hey, this topic is using this type of messages. Yeah? So this TF message is a type of message. So this is telling me which type of message is this topic using. So always one topic is going to be associated with a type of message. Yes? So each topic will contain one type of message. We cannot publish two different types of messages into a topic. Yeah? So for instance, let's say that in this topic we are going to be publishing strings. Yes? Then if we are going to be publishing strings, I cannot publish then integers. Yes? Another type of message, let's say. Yes? So each topic is going to be always associated to a type of message. In this case, this type of message is TF message. Then I'm also getting information about the publisher. So which ROS nodes, which ROS nodes, as we can see here, which ROS programs are publishing data into this topic. In this case, we have one ROS node, which is the Robot State Publisher, which is publishing data into this TF static topic. Yeah? And I have another ROS node, which is this one, the laser scan multi-merger, which is subscribed to this topic. So which is reading the information from this topic because he wants it for something. Yeah, he wants to get this information for analyze it or whatever. Yeah, so this topic has one publisher and one subscriber. Yeah, in this image here, we will have the topic here, which would be TF static. It will be the topic, and then we will have two ROS nodes, not three but two, and one would be a publisher, which would be this one, and the other one would be a subscriber, which would be this one. Yes? So far so good. Let me have a look at the comments and see if I have any question. Okay, I can see no questions, so I'm going to keep going. Guys, if you have any question or you don't understand something, just let me know here in the chat and I will try to answer you, all right? So I'm going to keep going, guys. Then, all right, so we know how to get a list of the available topics. We know how to get information about a specific topic. So now, from the command line tools, we can also publish data into a topic, yeah? So this is done with the ROS topic pub command. Pub from publish, of course, yes? So the command structure is like this. We are going to write ROS topic pub, then the name of the topic where we want to publish data, then the message type that we are going to use, yes, so the message type that is associated to that topic, and finally we are going to put the data, yeah, the specific data we want to publish. So for instance, here we have an example command, yeah, so I'm going to copy and paste this command here. Let me make this shell a little bit bigger, by the way, so we can see it better. All right. Then here we have our ROS topic pub. So publish. We are going to publish into a topic that we are going to name new topic. Yes? In this case, the topic we are going to publish, it's going to be named like this, new topic. Then this is the type of message that we are going to be publishing into this topic. In this case, we are going to be publishing strings. Yes? Strings which are defined in the standard messages ROS package. And then finally, I have here the actual data that I'm going to publish, yes? And the data that I'm going to publish, it's going to be this string, which says hello ROS developers. Yes? So let me execute this command here. All right. So I have published this topic, this message, sorry, into this topic. So now let me open another shell. Here I'm going to do a ROS topic list. And here let's try to find, here I have it. Yeah. So instead of trying to find it like this, which is a little bit hard when we have too many topics, we can also do a ROS topic list and filter using the grep function here, like this. ROS topic list, pipe, grep, and then I can filter for instance, new. Because I know that my topic has the new word, so I'm going to filter between all the topics, the ones that contain these characters, in this case, new. So let me filter here. And I can see that there is one topic that contains these characters, which is named new topic. This is the same name that I have defined here, yes? So now I can also use another command line, which we have here, that we learned last week, yes? So we are going to subscribe from the command line tools to this topic. This is done with the ROS topic echo command. So I'm going to do a ROS topic echo from the new topic. There we go. And I can see here the data that I have published into this topic. Yes? So I have this message into the new topic, which says hello ROS developers, which happens to be the message that I have published here. Yep. So now, for instance, I'm going to terminate this and I'm going to repeat the ROS topic list. What happens? Well, I don't have this topic anymore. It doesn't appear. Can you see it? Now the new topic, this one, it doesn't appear anymore. And if I do a ROS topic echo of this new topic, I can't see nothing. Why? Well, because I have terminated the publisher. Yes? Here I created a publisher from the command line tools, but I have terminated it. Yes? By pressing Ctrl+C. I have terminated this publisher. So now I am no longer able to subscribe to this topic or to visualize to this topic. Yes? All right. Let me have a last look here at the chat to see if I have any question. Why, if we start another subscriber to new topic, it will receive the message, but the first subscriber still received it only once at the beginning? Why, if we start another subscriber to new topic, it will receive the message, but the first subscriber still received it only once at the beginning? Okay, I think I understand what you mean. So this is because this topic, in this case, as you can see here, the publisher is latched. Yes? Here it says publishing and latching message. Yes? So this means that when I publish this topic, in this case I'm only publishing one message. Yes? Which it's this one, hello ROS developer, but I'm only publishing one message. But I am latching this message. As you can see here, publishing a latching message. What does it mean? That means that this message is going to remain there. Yes? It's going to remain in the topic. Then, at any time, if I subscribe to that topic, I'm going to receive this message. Yes, because it's latched. I have closed the subscriber, I can subscribe again, and I'm going to get that message again. Yes? This is because I am latching the message into the topic. Yes? So this message is going to be always there as the last message published. Yeah? That's the reason why. I suppose this is what you are asking. If I don't understood wrong the question, I think this is what you mean. Can more than says, okay, thank you. I didn't know the meaning of latching. Okay, you're welcome, Mikael. And then Sujay asks, can more than one node publish into same topic with same data type? Yes. Yes, it's possible, but you have to be careful with that. Yes, because there can be some problems associated to that. But yes, you can publish into. So for instance, let's try this right now. So I can do here ROS Topic new topic. I'm going to publish this message here. Yes, from one publisher. Then I'm going to subscribe to this to visualize here the data. And then I'm going to create here another ROS topic pub new topic. It's using standard messages string. And then here I'm going to put how are you? As you can see, the message is also published. Yes, we have received the message here from the new topic, yeah, and this has been published from one ROS node, and this has been published from another ROS node. So right now, if we do this, if we do a ROS topic info from the new topic to get information from it, what I'm going to see is that it has two ROS nodes which are publishing into it. So it has, well, the type is a string, of course, and I have two publishers, which one is this one and the other one is this one. And I have one subscriber, which is this one, this ROS topic echo I have here. Yeah? So yes, it's possible to publish in a same topic from different ROS nodes, but you have to be careful, of course, yes? Because it can generate problems in some cases. All right. So, okay, thank you. That's clear now. Excellent, Sujay. Okay, so let's keep going. Okay, so this is very nice and it's helpful in order to explain all these concepts. However, using creating publishers and subscribers and all of this from the command line tools has limitations. Yes, has some limitations. So in general, we are only going to use these types of commands like ROS topic poop, ROS topic echo for debugging purposes. Yes, for trying to debug some programs, to debug simulations, etc. Yes, to get information about the environment. But most of the cases, we are going to create our publishers with code. Yes. In this case, we are going to do it with Python, but they can be generated with C++ as well. So the thing is that here, as you can see, we can actually publish a message into a topic, but we cannot process this data. Yes, we cannot process it, modify it at runtime, etc. Yes, for all of this, we need to create a program, which is what we are going to do right now. So what we are going to do right now is to create a new ROS package where we are going to be placing different scripts. Yeah. So let's come here to our Catkin workspace, SRC folder, and we are going to create right now a new package with this command we have here. So Catkin create package publishers. I'm going to name my package publishers, and I'm going to add ROSPy dependencies. Why? Because I'm going to be creating Python code for ROS. Yeah, so with this command, I'm going to generate my new ROS package. There we go. And I'm going to be able to visualize it now in the IDE. If I open the IDE here, let me make it a little bit bigger. There we go. It's loading. Okay, here we have the shells. Well, I'm going to leave them open because probably I'm going to use them. However, I have too many. Here I have too many shells here, so let me close some of them. Let me close these ones, for instance, and this one as well. All right, there we go. So here I have my IDE, and inside my Catkin workspace here, I have generated a new ROS package which is named Publishers. Here I have it, and currently it's empty. So the first thing we are going to do is to generate a Python script which is going to demonstrate a simple publisher. So what is the basic structure to create a ROS publisher with Python? Yes, so let's come here and create a new file. I'm going to name it simple publisher.py, and then I'm going to come here and let me come here and select all this code, copy it and paste it into my script. There we go. Excellent. So here I have my code, and now let's quickly review this very quick. So first of all, we have this line which we are basically telling to the system that this is a Python script, as you can see here. Yes, so this script has to be executed with Python. I'm telling this to the system. Then I am importing ROSPy. I am importing the ROSPy module because I'm going to be coding and writing code for ROS in Python. Yes. Then here I am importing a type of message. In this case, I am importing the string type of message. Yes. So from the standard messages package, I want to import the string message. Why? Well, because I'm going to be using it in my code, so I need to import it first. Yeah? Then here I am basically creating a ROS node, ROSPy init node, which is going to be called simple publisher. So with this first line, what I am doing is to create here a new ROS node. Yeah? I am creating a new one here. Then in the next line here, I am saying, hey, this ROS node is going to be a publisher. Yes, you have a ROSPy publisher. So here I am saying that this node is going to contain one publisher. Yes. Then what about this publisher? Well, this publisher is going to publish into a topic which is going to be named new topic. Then this topic is going to be using messages of the type string. Yeah, and finally here I am defining the queue size. Yes, I set it to 1 because it's the default value, but basically this what means, well, this some years ago, I think 2 or 3 years ago, it wasn't required to put it, but now if you don't put it, you are going to see some warning, so it's better to just put it, and that's it. And basically here what you are defining is the size of the queue, as it says. So if the message fails to be sent for any reason, they are going to be buffered in a queue. And here I define what is going to be the size of this queue in case the messages cannot be sent to this topic. Yeah. Then basically this is what I'm defining here. Yeah. So I'm defining a new publisher which is going to publish into this topic, into the new topic, and it's going to publish string messages into this topic. Yeah. The next thing, what I am doing? Well, I am creating here a variable which is going to be of the type string. And here, what I am doing is to actually assign some data to this message. Yes, because here I am just creating it, but it's empty. Yes. Now here I am providing data to this message. In this case, I am assigning this string, which says, hello, ROS developers. Yes? And how... Alright, so let me explain real quick one thing here about messages in case you don't understand why this and why this. So, in ROS, there is a command also, which is to get information about messages. In this case, it's ROS message show. Then, if I execute this ROS message show command for the string message, I'm going to get information about this message. What is the structure of this message? So here I can see that I have two messages which are named string. One is in the ROS EUS package, and the other one is in the standard messages packages. Yeah, this is the default one, the one that comes with ROS by default. When you install ROS, this is going to be automatically installed in your system. Then what I can see here is that the string message contains one variable which is named data, which is of the type string. Yes, so this is the content, this is what the string message contains. It contains a variable named data which is of the type string. Yes, then here in the first line what I am doing is to generate this variable. Yes, I'm generating a variable which contains this, but it's empty. So here what I am doing, message.data, what I am doing here is to access, actually access this variable, this data variable, and I am assigning a value to this data, which is, in this case, this string. Hello, ROS developers. Yes? So this is basically what is happening in these two lines. Yes? So it's important always that you work with publishers, subscribers, etc. Well, in general, always that you work with ROS, it's mandatory that you know how to work with messages. Yes? In this case, this is basically what we are doing here. All right, then we have created our publisher, and we have generated a message here with some data. What are we doing here? Next, what we are doing here is to define a rate. Yes, a rate is going to be of 1 hertz in this case, and this is basically going to define which is the rate at which I'm going to be publishing this message. Yes? So in this case, here in this program, we are going to be publishing messages at a rate of 1 hertz. So 1 message per second, basically. Yes, we are going to see this right now. Then finally here, I am generating a loop which says while not ROSPy is shut down. So basically this means while my program is running, so while I don't stop my program, you are going to do the following. You are going to publish this message here. So here we are calling the publish function from this publisher element. Yeah, here we are generating a publisher element and assigning it to this variable, which is poop. Then from here I can call the publish function from the publisher AP, and I am going to pass here the message that I have just created and filled here. Yes, so basically here I'm telling, hey publisher, you publish this message, which is going to contain this value in this case. Yes, and then here I am going to sleep in order to make sure that this rate of 1 hertz it's accomplished. Yes, so basically I am going to be publishing this message 1 per second because I have here the rate of 1 hertz. Yeah, so far so good. All right, so let's test it real quick. So I'm going to come here. Let me come first to the publishers package, src folder, and here what I'm going to need to do is to give execution permissions, yes, to this Python file. So I can do this with chmod +x and the name of the file. So this is going to give it execution permissions. So now I'm going to be able to just execute this script with a rosrun command. Yeah, rosrun publishers. You have it here as well, the command, in case you want to copy paste it. Well, no, in this case we don't have it here. Okay, so in any case you have to execute the rosrun command. Yes, probably all of you know this command, rosrun, name of the package and name of the script, simple publisher.py. There we go. So now I have my program running. So let's see what is going on here. So in theory, I should be publishing this string into this new topic at a rate of 1 hertz. So let's subscribe here from the shell to this topic, ROS topic echo, new topic, and let's see what's going on here. And in fact, I can see here that a message is being published at a rate of 1 hertz constantly here, which says hello ROS developers. Yes, until I stop my program, which is, I have just stopped my program now, and the messages, as you can see, stop arriving to this topic. Yeah? Also, if I run again my program here and I do a ROS topic info of new topic, I'm going to be able here that I have one publisher, which is the simple publisher ROS node. Yes, and why it's named simple publisher? Well, because I have defined this name here, simple publisher, when I have created this node. Yeah? Alright, so here we have seen the basic syntaxes in order to write a ROS publisher with Python. Yep, super easy. So let me have a look at the chat and see if we have some questions here. Videsh Atki was asking, why do we write user bname Python? What does it mean? I have explained it some minutes ago. Videsh, I don't know if you heard it, but well, basically this is this line is telling the system that this script has to be executed with Python. Yeah, basically it's that. It's telling to the system that this script has to be executed with Python because it is a Python script. Path to Python interpreter. Yeah, I can see there Lucas has answered to Videsh. Yeah, sounds good. All right, guys. So how it is going until now? Any questions? Are you understanding everything perfectly? I don't know if I should trust you or not. Yes, sounds good, says Sujay. All right, I like that. All right, so let's keep going. I cannot see any questions, so I'm going to keep moving forward. All right, guys. So let's keep going. Then, okay, yeah. So we have seen this, but yeah, as I've just said, here we are publishing at a rate, in this case, of 1 Hz. So we are constantly publishing, yes? But in our command, where we tested our command before, here, we were publishing only a message, yes? However, from the command line tool, you have it here, you can also publish at a specific rate, yes? How this is done? Well, at the end of the command, you need to add this, yes? So with this command, the command we saw before, we are publishing only one message, yes? However, if we add here an error argument, and we are going to be able to specify a rate. So for instance, here I can set a rate of 1 again, yes? And this is going to keep publishing this message into a topic. We can check it again here with the ROS topic echo. Let's do it right now. And I can see here that as well, I am publishing the messages here from the command line tool at a rate of 1 Hz. Yes? When I stop the command here, the messages stop arriving. Yes? And you might be asking now, okay, but what if I want to publish only one message from a program? Okay. Be patient, we are going to see that in a moment, yeah, because it has some peculiarities. Yep. All right, so let's keep going. Then, here in these examples, until now, we have been publishing in new topics. So in topics that don't exist in the simulation right now. Yes? So now, if I do a ROS topic list here, I'm not going to be able to find this new topic. Yes, why? Let's do a grep, ROS topic list, grep new topic. So it doesn't exist. I don't have any match result here. Yes? So this topic, when I define this publisher, this topic is generated from 0. It's a new topic. Yes? However, in most of the cases, you are going to be publishing in topics that already exist. Yeah, so that is what we are going to do right now. We are going to publish into a topic that already exists. Yes, so in this case we got the program here, so let's create it. Let's first of all create this script. Let me define it here, new file, publish data.py. There we go. Then let me grab this code here, select it, copy it, and paste it here into my publish data script. There we go. All right, so here I have it. Then first of all, we can see one thing. We can see that we have switched a little, we have changed, modified a little bit the structure of the program. Yes, so this is linear programming, regular linear programming, which is okay because in this case it's a super simple program. However, in ROS, when creating ROS code, most of the time you are going to need to create classes, to work with classes, with object-oriented programming. Yes, otherwise your code is going to be a mess. Yes, so here I have basically adapted the structure of ROS Publisher to a Python class. You can see it here, and it's super simple. Yes, so basically here, as you can see, I am defining, let's say, this class, a new Python class, which is going to be named publish data. Yes? Then all classes always are going to have this init function. This init function is the constructor of the class. Yes? And always you create a Python class, it's going to have a constructor, an init function. Yeah? Then in the init function, usually what you do is to initialize everything you need for your program. Yes? So in my case, in the constructor, what I am doing here is to, first of all, create a publisher for this topic. Yes, in this case, this topic is a topic that already exists in the simulation. So if I come here and I do a ROS topic list of this topic, I'm going to see that it already exists. Yes, so since it exists, I can request information about this topic in order to know what type of message should I publish. Yes, so for instance, here with the ROS topic info command, I can know that this topic is going to receive, it has to receive twist messages. Yes, so into this topic I will have to publish twist messages. Yes, so I know this. Then when I define a publisher for this topic, I'm going to set the type of message to twist, as I am doing here. Yes, of course I need to first import this message. Yes, so next what I am doing is to generate this message, which is going to be of the type twist. And in this case, here I am giving the values to this message. Yes, so as you can see, in this case it's not data. Why? Well, because this twist message is different from the string message. Yeah, so in the string message, the structure of this message only contains one variable, which is named data. Yes, so whenever I provide the data to this message, I'm going to access this data variable, as you can see here in the simple publisher code. However, here I'm not working with strings, but with twists. So twist messages are going to have a different structure. Let's have a look at the structure of twist messages with the ROS message show command. And this is going to give me the structure of this twist message. And as I can see here, this message is different. So I have basically two variables here, linear and angular, and each one of them contains three more variables inside, x, y, and z. Yeah? So in this case here, I can see that I am accessing first the linear variable and then the x variable. So basically here, I am accessing this linear variable, and from within this message, I am accessing the x variable. Yes, so basically here I am assigning a value of 0.2 to this variable of the twist message. Yes, Let me have a quick drink. All right. Basically, I'm not going to explain more about twist messages, but basically twist messages are used in order to send velocity commands to the robot. Yes. So in this case, I am going to be sending a linear velocity in the x-axis. What does it mean? That the robot is going to move in the x-axis. So in this case, it's going to move forward. Yes, because this is the x-axis. So what I'm basically saying here is to set a linear velocity, a forward linear velocity for the robot. Yes, so this is what I am doing here. And then again, I am defining a rate as well here of 1 Hz. Yes, so this is for the constructor. Then whenever I call this class, all of this is going to be generated. Then for this class, I have defined another function which is called publish message. Then within this function, I have a loop here, which is going to keep executing while I don't terminate my program. And this basically what it's going to do, as you can see here, is to publish the message that I have defined and filled here, and I'm going to rate and sleep. Yes, just the same that I am doing here. Yes, but in this case I have it inside a class function, a class method. Yep. Then finally here in the main, what I am doing is to initiate my ROS node, which I'm naming publish data. Then here I start, let's say I create an object of the class, and then I call the publish message function, which is this one. Yes. So basically what should happen if I execute this program is that I'm going to start sending twist messages with the linear x velocity with a value of 0.2 to the robot. Yes? Well, I'm going to send it to this topic, to the robot, robotic base control command vel topic. Yes? So, let's try it. Let's try to execute this program and see what happens. So, let me come here to the CD Publishers SRC. I'm going to assign execution permissions to this publish data script. There we go. And now I'm going to be able to execute it with ROS run, publishers, publish data. In any case, I'm going to open also, I'm going to monitorize this topic to see what happens, okay? Do you agree? So let me copy here this topic name, Control C, and I'm going to do a ROS topic echo here of this topic. There we go. So right now there is no message in this topic. Yes? So nobody is publishing into this topic. But now I'm going to start my publisher. I am executing it here. And messages start arriving here. And as you can see, the message, basically, it has the linear x velocity to 0.2. And this, it's traducing in the simulation to the robot, as you can see here, moving forward. Yes? Okay, so let me stop the program. And let me stop the robot as well. So real quick, I'm going to set this velocity to 0 and publish it here so that the robot stops moving. I'm going to publish a velocity of 0. There we go. So I have stopped the robot. Yes? So as you can see, even after terminating the program here, the robot keeps moving. Why? Well, because the last message published is the one that the robot receives. Why? Because it's a latched topic. Yes? It's the same situation as we saw previously with the latched topic. Because it is a latched topic, the last message I publish into this topic is going the one that is going to be listened. In this case, by the robot. Yes? Make sense? Alright, so we have seen here how to create a publisher within a Python class, and publishing into a topic which already exists. And a topic to which the robot is listening, in fact. Yes, because if we do a ROS topic info of this topic, sorry, I don't know what I'm doing here, ROS topic info, what is this? Info, okay, so it's robotic base control, and command bell. So as you can see right now, this topic uses twist messages. It has no publisher right now because I have terminated my publisher program, and it has one subscriber, which is Gazebo, which is basically the simulation, and in this case it's the robot. Yes, so the robot, it's listening to this topic. So whenever I publish a message into this topic, the robot is going to receive it and convert this message into velocities of the robot so that the robot will start moving. Yeah, makes sense? All right. So we have terminated this section here. Let me have a quick look at the chat. Perfect. Yes, it's perfect. It's great. Yes. Please make a video localization of robot using computer vision, says Physics and Technology. Okay. I suggest you, Physics, to write a comment, a fixed comment when we load this video. Write a fixed comment on that video asking us this. Yes, because we are going to then read it and save it into a document for future ideas of videos. Is there a central place where you can see a list of all of the message type libraries such as standard messages, geometry messages, etc.? Yes, yeah, Mikael is saying ROS message list. Yeah, ROS message list, it's one. So for instance, here we can execute the ROS message list, and this is going to give me a list with all the available messages that I have right now. As you can see, there are many of them. So all of these are different type of message that I can use. Yes? So yeah, with ROS message list, you can get a list of all the available messages that you have. All right, then let's keep going because there are no more questions. Okay, so here basically what I am doing is to publish a twist message here into this topic at a certain rate. However, this I can also do it from the command line tools, right? So I can come here and do let me reset the robot position real quick. There we go. So this I can also do it from the command line. So I can do ROS topic poop, the name of the topic, robotic, command bell, here I define the twist message, and then I define here the contents of the message, and I set the linear velocity to 0.2. So this, and a rate, of course, I need to specify a rate here, a rate of, let's set a rate of 1 Hz. R1. So this is exactly the same, and the robot is going to start moving in the same way, right? Until I send a message with 0 velocity, which is going to stop the robot. Let's do it right now. Let's set the velocity to 0 and publish. And there we go. Yes, so this I can do it also from the command line tools. So what is the advantage that gives me creating a program for a publisher? Well, it gives you the advantage, for instance, to analyze data and do something with it. Yes? Do something with the context. So as we can see here, whenever I publish a message with a velocity into the robot, when I stop the program, the robot keeps moving, yes? And this is a pain because every time I need to to stop the publisher, then create another publisher with publisher 0 velocities. No. Let's create a program now that makes the robot stop when I terminate the program. Yes? So let's do that right now, and this, we are going to do it with this script here. So I'm going to create a new script, new file, process data.py. So let me now come here and grab this code and paste it here. There we go. Alright, so what am I doing here? Well, as you can see, it's very similar to the previous one. Yes? So I have the class with the constructor, and the constructor is the same, except this last line here. Yes? So basically here, what I am saying is, hey, on shutdown, so when this program is terminated, you are going to call this function, the shutdown function. Yes? We are going to see later what this function does. Then we have the publish message function, which is exactly the same as here. And here I have the definition of the shutdown function. Yeah? So basically, this is the same with this added line, which says, hey, on shutdown, you are going to call, when you close this publisher, when you terminate this program, when you terminate this publisher, you are going to, before terminating, you are going to call this shutdown function, which I have here. Then in this shutdown function, what I am going to do is to set this linear x velocity to 0 and send the message, so that the last message that is going to be sent to the robot is going to be a 0 instead of a 0.2. So this is going to stop the robot. Yes? So let's test this. Then going to come here to my shell where I have it. Again, I have 2000 shells, so let me close some of them. Okay, there we go. Okay, so first of all, as always, let me give execution permissions to this new program, process data. And now I'm going to execute it. Publishers, process data.py. So I am starting publishing velocities, the robot starts moving forward, but now when I terminate my program with a Ctrl+C, for instance, let's do it here, the robot stops. Why? Well, because when I have terminated, when I have shut down my program, this shutdown function that I have added here has been called, and this, inside this function, I am setting the velocity to 0 and publishing it as the last message. Yes? So here, as you can see, we are analyzing the situation and publishing messages depending on that. Yes? So this, we cannot do it from the command line tool. Yes, this is why it's, in most of the cases, you are going to need to create programs, because with programs you can do these kind of things. You can decide which data publish depending on the situation. Yes? Excellent. So I see that we are already passing 7 minutes from the time. So let me try to explain this, which is, I think it is the last thing we have. Yes. Yes. Okay. So until now we have been publishing messages at a certain rate. Yes, as you can see here. So we are publishing messages at a certain rate. Yes. But what if I want to publish only one message into a topic? I want to publish one message and that's it, no more. Can I do this? Yes, you can do it, but it has some peculiarities. So let's get this code here, publish once.py. Let's copy it and let's paste it to a program. I'm going to do this right now. Let me create one new script, which is going to be named publish once.py. There we go. I'm going to paste the program. Yes? So basically this, as you can see here, it's exactly the same program that I have here, but I have removed here the while. So instead of a loop, I'm going to publish only one message here. Yes? So let's see what happens. Let's try to execute this program. One more time, give execution permissions to this publish once script. And I'm going to execute it. ROS run publishers and publish once. And nothing happens. So now the robot is not moving. Interesting. So why the robot is not moving? Let's see what is going on here. So let's do a ROS topic echo of our topic, robot. Damn it. Robotnik, base control, command bell. Let's monitorize, let's subscribe to this topic and see what's going on here when I'm running this program. So let me run it one more time. Publish once. And nothing is being published. Okay, this is strange. So my messages are not being published. Why are not being published? As you can see here. So now that I'm only publishing one message without the rate, my messages are not being published. Why? Do you know, guys, why? Well, this is because when we create a publisher, it needs sometimes, it's very small time, milliseconds, in order to create the connection with the topic. But it needs sometimes. Yes? It needs some time, sorry. Then, if we publish with a rate, this time is going to be achieved, yes? So maybe at the beginning, the first messages are going to be dropped, but at the end, since I am constantly publishing, my messages are going to arrive to the topic, yes? However, here, the program execution goes too fast. And when I reach this point, when I am publishing the topic, the connection here to this topic is not yet ready. And because this connection is not ready, my message is being lost. It gets lost. Yes, it's not published. Yeah? So this is basically what is happening. Then what happens? I cannot publish only one message because it's going to be lost. No. You can actually do one thing, which is to use some publisher functions like we have here. So here, I'm going to grab here you have the code, I'm going to get only the function. Let me copy it and paste it here to my code. I'm going to add it here below the shutdown. There we go. So here I have added a new function that basically what does is to check the connections of the publisher. Yeah, this self pop is this publisher that I have done here, and here I'm calling the get num connections. This function is going to return me the connections of this publisher. So if this publisher is successfully connected to this topic, it's going to return me a number, which is going to be higher than 0. Yes, it's going to be the number 1 in this case. Yeah. Then what I am doing here is to verify if this number is higher than 0, then and only then I am going to publish the message. If not, I am going to come back here to the while loop and check this again. So it's going to be constantly checking until this function returns a number higher than 0. Yes? So this way I am making sure that my publisher is properly connected to the topic. Yes? Then here, instead of directly publishing, what I'm going to do is to call this function. Publish once in topic. Here I have it. And the same here, instead of publishing using directly here, I'm going to use this function, publish once in topic, which is going to only publish once it is sure that the publisher is ready and connected to the topic. Yes? Make sense? So now I can repeat here. I can try to run one more time my program. Well, let me run it here. And let me have this as well prepared and the robot here. So now I'm going to run my program one more time. Oops, sorry, I have done some mistake here. This is publish once in topic. And let me see, I don't see. Oh yeah, because I am calling the publish once in topic from the publisher, and it's not from the publisher, it's a method from the class. So I call it directly from self. Yes, not from the publisher object. I call it from self because it's a function from the class. Yeah? Then let's go one more time. Let me visualize the robot here. And okay, so as you can see, the messages now are published 0.2 and 0.0, but the robot has not moved. I don't know why. Maybe it was a bug. Okay, I know why. I know what it has been, because I have moved the robot here from. Damn it. Okay, so let me do one thing. Let me reset the simulation here. This should reset simulation. This should do it. Okay, yeah, I think this should do the trick. Here I have the echo, have resetted the simulation. So if I call this now, it's not yet moving. Yeah, it's a problem in the simulation. So I would need to, as you can see, the messages are being published, yeah? 0.0, 0.0. So the messages are arriving, but I would need to restart the simulation here for the robot to move, I think, because I have touched there and moved the robot, and probably I have messed something around there. So yeah, is it clear? Any question? So far so good. Do you understand this new code? Guys, does it make sense? Let me have a look at the chat to see if I have any questions here. Okay, is there a central place? Okay, I already answered that. Is there any difference between RVs and gazebo simulation? Yes, many differences. So gazebo is actually a simulator, yes? So it's a simulator of a real environment. RVs, it's only a visualization tool. So, yes, so RVs, so in gazebo you are calculating the physics of everything. Yes, so all these are being, it's calculating physics, everything. Yes, so this is just as a simulation of a real environment. Yes, RVs, it's only a visualization tool. Yes, it's not simulating anything. You are just visualizing things. So it's a totally different concept. Yes. Oh, of course. I'm stupid. So yeah, of course it's not. The robot is not moving because I am starting to move it by automatically. In a moment, I am sending a 0 velocity. So I sent a 0.2 to start moving it, but then I sent a 0 to stop it. So that's why the robot is not moving. Yes, so stupid. I didn't show that. So in this case, what we should do is to remove this line here, so that the robot, so that I don't publish the 0 command. Yeah. So let me subscribe here one more time, and now I'm going to only publish the velocity command, not the stop command. Yes. And the robot is not moving yet. Well, I don't know what's going on then, because the message is arriving. Yeah, some problem in the simulation, I suppose. Okay, well, anyways, it is understood because you can see perfectly here that the message is being sent to the robot. All right, so let me keep checking here the messages. Is there a default value to the rate? No, you can set chill operator. No, you can set the rate you want. 1 Hz, 10 Hz, 5 Hz, whatever. Would you advise to use publish once in topic for all nodes publishing? Your robot stops because of shutdown. Yeah, Mikael, yeah, I just realized that. Engineering Nation says, yes, the idea of the new function publish once in topic makes sense. And Mikael was asking, would you advise to use publish once in topic for all nodes publishing? No, it depends on the situation, Mikael. In some cases, maybe you need to keep publishing messages. And in other cases, maybe you just need to publish one message and that's all. And it makes no sense to keep publishing the same message forever. Yeah, let's say that you, in order to trigger something, you need to publish one message into one topic. And then by publishing that one message into that topic, that is going to trigger a system that is going to start working by its own. Yes, then it makes no sense to keep publishing messages into that topic because you are consuming resources, etc. for no reason. Then in that case, you are going to prefer to just publish one message into that topic and then stop publishing, and that's it. In other cases, you are going to need to keep publishing messages because, for instance, you are going to need to change the values or the messages that you are going to be publishing there. Yeah, makes sense? So for instance, I'm not going to show it here because we are already 20 minutes past the time, but here I have a program that I have added here that, for instance, I am creating two different publishers in the same node because in the subscriber class last week, somebody asked, is it possible to create different subscribers in one ROS node? Yes, it's possible. And it is possible to create more than one publisher in one ROS node, as you can see here. So here, for instance, this program, I'm going to just copy it and execute it, but I'm not going to do anything else. So you can test it and everything now, when the class finishes. You can review this program and see what it does. I'm going to name it square.py. Real quick. There we go. There we go. Plus x square.py. And now I'm going to run it. ROS run publishers square. Have a typo there. Yeah, so basically, as you're going to see here, this program, what it's going to do is to make the robot move doing a square. Yeah, so I'm going to stop it right now, ROS. But now it's going to crash against. Let me stop it real quick. ROS topic, pub, robot. Let me stop this. Let me reset it. Let me try to move it. I've lost my simulation. There. Okay, there it is. Jesus. There we go. And there we go. Okay. So basically here, I am changing the velocities I am sending to the robot in order to move forward, now to move to the left, you are going to see, now to move backward. Yes? So for instance, in this case, it is going to do a square. So for instance, in this case, I need to keep publishing messages because I am changing the values I am sending to the topic. Yes? So in this case, it's more advisable to keep publishing messages. So it depends on the situation. Yeah, basically this is what I wanted to explain. Makes sense. Thank you. Okay, great, Mikael. So yeah, that's all. That's everything for today's class. I hope you enjoyed the class. We are 23 minutes past the time we should have finished it. Oh my god. Okay, so let's stop it right here. I hope you liked the class. I hope you learned something new about publishers and you feel now more comfortable on working with ROS publishers. So yeah, that's it. As always, keep safe, guys. Stay home. Don't go outside if it's not extremely necessary. And I will see you again next week for the next live class. So goodbye. Thank you all of you for being one more week here with me in the live class. And I will see you next week. Bye bye.